Today, we're going to talk about linear programming. The essential question of the day, how can I solve linear programming problems? And this is a 2-day lesson, so today is day 1. Well, who uses this? If you're going to be a landscape architect someday, you can use linear programming to determine which plants to plant on a green roof.
Oh,
Yeah, so
that's pretty cool.
so this is a key term, constraints. I'm going to use a real life example. Landscape architects choose different types of plants depending on different constraints. So they're going to look at how much do the plants cost, the price, the amount of water that the plant requires, and the amount of carbon dioxide that they absorb. Those are different constraints that an architect takes into account when determining what plants to buy. As a mathematician, we're going to do the same thing. In linear programming, by the end of, I think we teach it a little in day 1, but we really get it good in day 2, we are going to use linear programming to find maximums or minimums of functions.
So the region between things.
Correct.
Got it.
But in order to do that, we have to satisfy constraints.
Okay.
And a constraint is an inequality. It's one of the inequalities in a linear programming problem. Miss Boyd is highlighting that. You should too.
Yes.
So now the solution. You all want to know, well, what's the answer going to be?
Mm-hmm.
Well, the solution to the set of constraints, we're going to graph it. So you're going to get a bunch of constraints as inequalities. You already know how to graph inequalities. You learned that in 2.5. So we're going to graph these inequalities and we're going to shade. Where all of the shadings overlap is our feasible region.
Perfect.
That's all we're doing. So I would highlight, or I would recommend, bring colored pencils to class. It will be helpful. Bring highlighters to class. It will be helpful. Even bring a ruler if you have one
that'll help.
laying around, because graphing accurately is critical to getting this right.
Okay.
Example 1. Yum's Bakery bakes 2 types of breads.
All right.
We have bread A and bread B. And so what we're going to do, we're not going to color code based on A and B,
No.
but we're going to color code based on what the bread is made up of.
Okay.
Okay? So every time we see oats, we're going to color that a certain color, yellow.
Yellow.
So it's talking about A and B.
Okay.
One batch of bread A uses 5 pounds of oats and 3 pounds of flour. So now we're going to change our color for flour. Okay, blue. That's all right. We'll fix that.
There we go. All right, 3 pounds is going to be, or flour is going to be blue.
Yep, so there we go. That is A.
Okay.
Now, one batch of bread B uses 2 pounds of oats. We're back to yellow again.
Boy, I hit yellow.
We're struggling, aren't we? We got it. It's been a long day.
There we go. It has.
2 pounds of oats and 3 pounds of flour. There we go. The company has 180 pounds of oats. So again, back to yellow. And 135 pounds of flour. Look at that.
All right.
Write the constraints for the problem and graph the feasible region. Now notice how much time Miss Boyd and I took reading that problem.
A lot.
A lot.
You gotta underline those keywords.
Have to highlight and underline. So, all right, let's write. Can you write an equation for me right now?
Sure.
Would you just write the word bread?
Sure.
Bread equals oats plus flour. That is important.
Yeah, you have to have oats and flour
batch
to make
of bread, A and B, is made up of oats and flour.
Okay.
So now we're going to write our constraints. Notice we define the variable for you. Variable X is going to go with bread A.
Okay.
And variable Y is going to go with bread B.
Okay.
So, okay, 2 constraints that are always going to occur, always, is this. X, and I'm going to have, perfect. X is greater than or equal to 0.
Oops, greater than.
And then we'll talk about it. And the other constraint right underneath it is Y is greater than or equal to 0. Well, common sense.
You have to have more than nothing when you make bread.
You can't make a negative number of batches of bread.
Okay.
And X refers to A, Y refers to B.
Got
Okay,
it.
let's go on to the next one. Now I'm going to have Miss Boyd write this. 5X plus 2Y is less than or equal to 180. So let's talk about that.
Okay.
Okay. We know that bread A is made up of oats and flour.
Yep.
Right? So each batch of A uses 5 pounds of oats. So
Okay,
that's
up
why we
here.
take 5 times X.
5 times X.
Because X is the number of batches of bread A.
Okay.
Plus, it is made up of, plus bread B is made up of 2 pounds of oats. Thus, 2Y. That's less than or equal to 180 because
That's how many oats
yes,
the company has.
the company is going to use, we're going to use 180 pounds of oats between bread A and bread B.
So I'm just writing oats for both breads.
I like that. I like
That's
that.
how it makes
Right.
me remember.
So we're made up of oats. Well, what's the other ingredient, Miss Boyd?
Flour.
Right. Well, let's go back. Okay, well, bread A uses 3 pounds of flour, so that would
Okay.
be 3X. Bread B uses
3 pounds of flour.
3 pounds of flour.
So 3Y.
3Y is less than or equal to
And this time it's
135. And the reasons it's less than or equal to is because it has 180 pounds of oats and 135 pounds of flour and no more than that.
Right.
That's the maximum we can use. So we have to do
Got
the
it.
less than or equal to.
So those are
There's our
constraints.
constraints.
Awesome.
Right, let's move on. And oh boy, look at all that space we have. Okay, so let's go to the next one. We wrote the constraints. The next step in this whole process is graphing them.
Okay.
So as you can see, Miss Boyd, right
Yeah.
there, those are the constraints that we just wrote for the students.
Right.
Right there.
So in blue, X is greater than or equal to 0. So
Yep.
it's where it crosses the X-axis at 0.
Right.
So this is a, tell me if I'm wrong, a vertical line.
Right.
Yes.
It's right there.
So here's our X.
And it's a solid line, notice, because less greater than or
Yeah.
equal to.
And it's greater
Yep.
than or equal to.
Yep.
So I'm going this way
Right,
with my blue.
right,
This is where different colors help.
right. Now I wonder, should we shade all of our lines first and then, or should we draw all of our lines first and then shade?
I like to do it all at once so I don't get mixed
Perfect.
up.
Okay, we're going to do what Miss Boyd wants.
Thanks.
Okay,
So now I'm
y
gonna
is
do
greater
it
than or
in
equal to
red.
0. Okay, perfect.
And so that's this line.
All right.
Where it crosses the y-axis at 0.
Yes.
And it's greater than or equal to, so it's going up.
Nice.
So
far, look at,
it's
we're overlapping everywhere.
yes. All right,
Oh
next
boy.
one.
But we have a problem now.
Ooh.
What do we have to do
We
before?
have to put it in a y equals format.
And actually, I'm going to give you a suggestion right
Yeah.
now. The easiest way to graph a big number like that is
Mhm.
to find an x-intercept and a y-intercept.
Oh,
It
perfect.
is so much easier.
That makes sense.
So let's do that. Let's find, and you guys know how to do that.
Yes.
So we have room down below if
Okay,
you want.
perfect. I'll
So we'll
bring it
just
down.
rewrite it as,
So 5x
Mhm.
plus 2y is less than or equal to 180.
right,
Oh boy. Okay, so we're just plugging in 0.
right.
So I'll plug in 0 for y to find my x.
Yep,
So I got 5x plus 0 is
Yep.
less than or equal to 180.
right,
I'm solving, so I just divide by 5.
right.
So I get x is less than or equal to,
36.
all right.
Does that sound right for
It
the math?
does.
Yes, yes.
So
So,
can we go
our-
by tens?
yeah, but let's plot our point. What's our point going to be? What's our x-intercept? It's going to be 36, comma 0, right?
Yes.
So let's write that. 36, comma 0. That is our x-intercept.
Right.
So
I'm gonna
let's
go
count by
can we go by
tens. Please do.
So this is 10, 20.
Yep.
Oh, yeah. 30,
Yep.
40,
Mm-hmm.
50.
Yep.
Do we need more? Or are we good
We're-
for now?
We're good. And then
Okay.
let's go along the x-axis.
Okay, so we'll go 10,
10,
20, 30,
Mhm.
40,
50.
50, 60,
Right.
70. All right.
So if we're going to plot the point 36, 0, where is that going to
Yes.
be?
Well, I'm going to go over 36,
Right.
which is just right before the 40.
Yeah, that sounds good. And that's
and
it.
0. So I'm going to put my dot right there. 'Cause
Okay.
I'm doing yellow
You're
right
doing,
now.
okay, got it.
I'll just do this then so we know it's yellow.
Yeah. But now we got to find a y-intercept.
Yes.
So I'm wondering, do we have, how much
Yeah,
room do
just
we
do it
have
right
down
next
below?
to it.
Should I give you a little more space to work though?
Sure, you can try.
Oh, we do. We do.
Yes.
We do.
All right, that's
Plenty.
good.
I know it's moving though.
That's okay.
Stop. Okay.
Ah,
Should I tell you the equation
so, sure.
again? It's
5x.
3x.
No.
Oh yeah, sorry, 5x.
2y is less than or equal to
180.
180.
Mm-hmm.
So now I'm plugging in 0 for
For
my
x.
x. So I'm left with 2y is less than or equal to 180.
Divide by 2.
Divide by
you get
2,
96.
I get Should get 90.
90, yeah.
Okay.
I know. I told you guys I can't do math
It's
in my
okay.
head. I
All
just
right.
proved it.
That's okay.
So what's our
So
point?
Our y
0, 90.
intercept, yep, so it will be 0, 90.
Yep.
So we don't go left or right any, but we
No.
go up 90. So I'm going to have to
Right.
make that graph just a little bigger.
Oh, yeah.
It's okay.
You're right.
All right.
Okay.
So 50,
60, 70, 80, 90. Right there.
Oh boy, I put 80 because we were talking.
I know.
It's okay. All right. So 90. So that's our other intercept.
Yes.
So I'm going to do that there.
There we go.
And then I'm just going to
Graph your line.
make my line.
Make it
to get
solid.
there.
And now we can't really look at the less than or equal to and determine that we're going to shade below. Remember? We
No.
got to use a test point. We
Test
probably
point.
do that in our head though. Look at it,
Yes.
right?
We do 0, 0.
Zero plus
is
zero is
0 less than
Or equal to
180.
yes, so you're going to
Yeah.
shade below for sure.
So we're shading down here.
Yeah, there we go.
And you
So-
notice I didn't go past my other constraints because I know there's nothing over here, so there's no reason to go down there.
Right.
So I'm just shading there.
Exactly.
And
so
the last
now we have to find the. Do you need more? You mean
one.
no,
hold
you're good.
on. I'm
okay,
just
hold
gonna
on.
underline this in green so we know it's going to
And
be
we
the green
could
one.
go over here in the
We could.
sidebar.
Let's
Why
do
don't we
that.
do that?
All right,
3x,
so 3x
plus 3y,
plus
but that looks like a
3y,
y.
I know. There we go.
Okay.
Less
so-
than or equal to 135.
right. So let's find our x-intercept.
All right, so plug in 0, so I
Mhm.
get 3x is less than or equal to 135.
Mm-hmm.
X
And
equal or
45.
less than or equal to 45.
so our
I
point
got
is 45, 0.
0.
There we go.
So I'm going to quick plot that in
Okay.
green. So
Yep.
over 45, here's 40 halfway.
Right there.
There?
Perfect.
Oh boy, that looks black.
There.
Eh,
That's fine.
Okay. And then the next one,
Is
we got to get the y-intercept.
Yep. So we got to set
So
x equal to 0.
135. X is now 0. So, oh, it's the same thing as young
Oh.
because we still have
Oh
3.
yeah. What were we? Yeah.
That's all right.
That's right. So
y
0,
is less than
45.
or equal to 0. Oh,
So
well, 45.
yeah. And the other point then is 0, 45.
All right.
There we go.
So, up 45. Here's
You're
40. Here's
right
halfway.
there. Good. And we connect. the
And now we
dots.
connect our dots. At least I
Yikes.
tried to. Our light turned off.
There we go. Our
All
light's
right, we're back on.
Okay.
Perfect.
All right. And test to 0, 0. Again, it's pretty obvious. 0. If you plug in
Yes.
0 for x, 0 plus 0, is that less than 135?
It sure
Shade
is.
below.
So I'm going to shade below. And again, I'm just shading to my constraints that I've already set up.
Right.
So our final answer
It's kind of tricky
is
if you
every,
look.
So here's our one constraint.
Yeah.
Here's our other constraint.
And it only goes over.
and only to the green.
But that's actually, we got to be really careful,
gosh,
remember?
Because of this yellow line.
Yeah. Yeah.
Dang. So we're going to have 4
Yeah.
constraints.
Yeah.
So I'm going to quick erase this one.
Okay.
Because
Got
that
that?
one's technically not there.
Right.
Because this one went there.
'Cause
And we got to stop at that yellow.
Right. So actually a
Ooh.
vertice should be 0, 0.
Yes, right here.
Yep. And the other vertices should be 0, 45. Which
Yes.
is, no, that's 45, 0. So
Oh,
it's-
yeah, yeah.
Yep,
0,
045, which is right there. The other one should be 36, 0.
Yep.
Yep, got
Oh.
that. That's over there because
Oh,
of
you're
the yellow,
right.
remember?
Gosh, I'm getting mixed
Got,
up.
yep.
Yes.
And then the other one should be 3015, which is a corner.
Yes, right here.
3015, which is a corner. Yep. So those
Approximately.
approximately.
So then we
So
would
how
shade
can we get that?
everywhere.
There we go.
To these vertices.
Yeah. Yes. And we're going to write our
We're gonna do a lot of
vertices.
practice.
Yeah, this is going to take a lot of time in class for sure.
Okay.
So down below, let's write
Yes.
our vertices so they have them.
Okay.
So the vertices are you ready? I'll read them
Yes.
off to you. The vertices are 0, 0.
Okay.
Yep. Another vertice is 0, 45.
Good.
36, 0. And 30, 15. Those are the vertices, and we will
Got
go over this more in class
Yes.
for sure. All right, so now we talk about bounded and unbounded. And I'm thinking what we're going to do right now is we're going to just quickly talk about it.
Okay.
Then I think we're going to
More in
stop.
class.
Yeah, I
'cause
think
this video's getting
it's
long.
getting really long.
Okay.
So we're going to talk about bounded and unbounded regions. And basically, I'll
Oh.
talk about objective function in class.
Yeah.
I'm going to skip that right now.
Perfect.
All this means is that when you have a bounded region, that means it has a max and it has a min. Or, so in this case, objective function has both a
Yes.
minimum and a maximum. And is what I meant to say.
Right.
And if it's unbounded, it could have a max or a min, but it doesn't have both.
So see
That's
right here, there's
unbounded.
no line, so it's
Correct.
unbounded. Here, there's no line, so it's unbounded.
Right.
Okay.
And so then the last part of today is, if you have an objective function that has a maximum or a minimum, it must occur at one of the vertices. That's why
makes
finding the
sense.
vertices are so important, and you need it exact.
Okay.
So let's go to the next page. And we're going to do this in class, and we're going to do this in class,
Perfect.
and class, and done. Here's your
Perfect.
video questions. Please take the time to and be
Yes.
honest. Thank
Thank
you
you.
so very much, and we will see you tomorrow.
Tomorrow.